Hello dear students, let us solve a long answer question from Sample Questions Set 2. The question part A is, a railway truck of mass 4 into 10 to power 4 kg moving at 3 meter per second collides with another truck of mass 2 into 10 to power 4 kg which is at rest. The couplings join and move off together. What fraction of first truck's initial kinetic energy remains as the kinetic energy of two trucks after collision? Solution of part A. Given, suppose this is truck first, moving the velocity u1 is equal to 3 meter per second of mass 4 into 10 to power 4 kg. This is second truck of mass m2 is equal to 2 into 10 to power 4 kg. At rest means u2 is 0. When they undergo collision, both move off together with common velocity v. So total mass will be m1 plus m2 is equal to this plus this means 6 into 10 to power 4. We have to find half m1 plus m2 into v square upon half m1 u1 square. That is fraction of first truck's initial kinetic energy which remains as the kinetic energy of two trucks after collision. Now from linear momentum conservation, in this case total initial linear momentum is equal to total final linear momentum, means m1 u1 plus m2 u2 is equal to m1 plus m2 into v. This is 0. Therefore v will be equal to m1 u1 upon m1 plus m2, which gives 4 into 10 to power 4 into 3 upon 6 into 10 to power 4. Upon 6 means 2 meter per second. Therefore, desired ratio will be 1 by 2 m1 plus m2 into v square upon 1 by 2 m1 u1 square. Values are known. m1 plus m2 means 6 into 10 to power 4 into v is 2 square. Here 4 into 10 to power 4 into u1 is 3 square. This cancels out. 4 into 6 24 and 9 into 4. So this is 24 upon 36 means 2 by 3. Therefore the required ratio will be 2 by 3. Question B is, a loaded grocery car is rolling in a strong wind. A force of 30 I minus 40J Newton displaces the cart through 9I plus 3J. Solution of part B. Work W is equal to dot product of force and displacement. Force is this one and displacement is this one. Again we know that I dot I unit vector dot I unit vector is equal to J unit vector into J unit vector gives 1, and I unit vector into J unit vector is equal to 0, etc. Therefore 30 into 9 I dot I minus 40 into 3 J dot J, remaining terms are 0. This is 1 and this is 1. 30 into 9 is 270, 40 into 3 is 120. This gives the required work done as 150 joules. Part C. A uniform ladder rests on a rough horizontal ground, leaning against a smooth vertical wall. Weight of the ladder is 300 Newton and a man weighing 500 Newton stands on 1/4 of its length from the bottom. Find the reaction at the wall and total force on the ground if the ladder makes 30 degree with the horizontal. Solution to question C. Here given, suppose this is vertical wall, this is ground, and this is ladder inclined at 30 degree with the horizontal. Suppose A, B is ladder, A, B is equal to L is equal to length of ladder, weight of ladder is 300. Suppose it will act at its center C. Weight is F1 is equal to 300 Newton. F1 is equal to 300 Newton. Weight of ladder. A person at 1/4 of its length, means at point D, stands at point D. Suppose this is D. Its weight will be F2. F2 is weight of man at D, where A to D is 1/4, means AD is equal to L by 4. This is center of gravity of ladder. Therefore AC will be equal to L by 2. We have to find the total force on the ground and normal reaction. R is the normal reaction and we have to find the force on the ground. Solution. We have to find first R, normal reaction at wall. Second, total F, total force at A on the ground. Solution. First part. Applying principle of moment, about point A, we get. Principle of moment says that total clockwise moment is equal to total anti-clockwise moment means F1 into this distance plus F2 into this distance is equal to R into this distance. Suppose this is O. So F1 into F1 into AP, F1 into AQ plus F2 into AP is equal to R into BO. Clockwise moment of F1 plus clockwise moment of F2 is equal to anti-clockwise moment of normal reaction R. Now F1 is 300, AQ is L by 2 cos 30, L by 2 cos 30 plus F2 is 500 into AP is L by 4 cos 30 is equal to R into BO. R is unknown and BO is L sin 30 L cancels, we get L gets cancelled. This is this is 150 cos 60, this is 125 cos 30, this is 150 cos 30, 125 cos 30 is equal to R sin 30. So R will be equal to 150 plus 125 gives 275 cos 30 upon sin 30. This is 275 cos 30 means root 3 by 2, sin 30 is 1 by 2. On simplification we get R is equal to 275 root 3 Newton. Second part. This is vertical line. Let the resultant force is F at point A, which makes angle theta with the vertical. Let the resultant force F at A makes angle theta with the vertical. Then its vertical component will be F cos theta, and horizontal component will be F sin theta. This is horizontal component, this is vertical component. Then for equilibrium, vertical upward force must be equal to vertical downward force, means F1 plus F2 vertical downward force must be equal to vertical upward force F cos theta. This is equation 1. And horizontal rightward force is equal to horizontal leftward force, means horizontal leftward force is R must be equal to F sin theta. Equation 2. Equation 2 upon 1 gives F cancels out, tan theta is equal to R upon F1 plus F2. Values are R, values of R and F1, F2 are known. This is 275 root 3 upon F1 plus F2 becomes 300 plus 200. This is 300 plus 500, 800, which gives theta as tan inverse of 275 root 3 divided by 800, which is 30.77 degree. 30.77 degree. Now equation 2 gives F is equal to R divided by sin theta. R is 275 root 3 upon sin 30.77 degree, 554.9, 554.4 Newton. 4 Newton.